Now let's look at type checking for let type and match. For let type by itself, there's not too much to check. Any type name and variant name should be okay, and the type of the overall expression should be the type of the body on the inside. If the body is 1, we want int t. If the body is the variant, apple 1, we need the type of this variant. That is fruit, so we use define t. Also, if the body is a banana variant, we want the same type. Banana is also a fruit. Now for match. This is a bit more tricky. If we were interpreting this match expression, we know that we would go down this first branch, and the result would be whatever a is bound to. So that's an int 3. When we're type checking, though, we don't necessarily know the value of this expression that we're matching on. We really need to interpret the expression to know which branch to go down, but our type checker is not going to call interp. Instead, for match, we need to make sure that both branches end up with the same type. And in this case, that type is int t. Either a is an int, or we call b of 7 and get back an int. Again, just like with an if, match results all have to have the same type. Now, how do we know that a is an int? We get that from up above with let type. It says that the argument is an int. This means that when we're type checking a let type, we'll need to extend the type environment with information about these two variants. That way, when we get to a match, we know which type to unpack to. Also, we'll need to check that these two variants in the match line up with the type that we're matching on. We need to check that apple and banana are both actually fruit variants. If we had a different expression, here's a match where the first case says radish instead of apple. This one should be a type error because radish is not a fruit. Our type checker has to know those variant names that got created with a let type. One more example. Here, in the banana case, we're returning just b instead of b applied to 7. This one should be a type error because b is a function. And again, in order for type check to raise an error, it needs to know those variant types. So we will have to extend our type environment with all that information when we go to implement the type checker.